Dr. Richards. Holy cow, what a saga. Yeah,
Good to
lovely
see
to
you.
see you.
Good
And
to see you. Andy Aldrin.
Andy, how are you? Great to meet you. Yeah.
Hello, everyone.
Well, you know who they're waiting for, so
Yes. I think we have
roll
exactly
the
a special appearance. We should
Yeah.
roll tape?
okay.
All right.
And then
Let's
I'll
do
leave
that.
you.
Will do.
This is Buzz Aldrin, and it's an honor to participate in this Idea City event. A lot of you know that I've spent a great deal of my life thinking about, talking about, and even floating around in space. In fact, I recently published a book in which I lay out my vision for how humanity can move step by step to a permanent presence on Mars. In the 45 years since I walked on the moon, a lot has happened in space. We built the space shuttle, the International Space Station, literally hundreds of exquisite scientific missions around the Earth and to other planets. We've developed space-based telescopes which tell us that the galaxy is populated with literally thousands of Earth-like planets. But a lot hasn't happened as well. When I returned from the moon in 1969, I think most of us believed that by now we would have permanent settlements on Mars. Why not? Well, I think that part of the problem is that space has been a purely governmental adventure. The private sector has largely been on the sidelines, building only what the government paid for. Well, that's beginning to change now. And I think it will fundamentally change the way our civilization develops and exploits space. We are already seeing the commercial development of suborbital passenger travel with Virgin Galactic and X-Corp. Soon I expect to see the commercial development of orbital passenger travel. Now that my son Andy is president of Moon Express, I also expect to see the next U.S. landing on the moon to be by the private sector, building on the accomplishments of Apollo, with a new paradigm of commercial lunar activity that unlocked the moon's resources and leverage our pathway to Mars. I also expect Andy to be supportive of my Unified Space Vision Institute, in addition to his Moon Express, but also the United Strategic Space Enterprise analysis of our policies in the past that lead us to where we are now and the future. And now with that, I'd like to introduce you to my son Andy Aldrin and Bob Richards from Moon Express.
So, everyone, it is, I have the clicker here for my presentation, please. Thank you. It's such a pleasure to be back on the stage here at Idea City. One of the things that happens in space today that didn't happen back in the day is the rapidity with which things are moving forward. You know, our entire civilization has grown up here. Every one of us that has ever been born, every human being who has ever lived, thank you so much. Everyone we love, all the history, conquest, of fantastic works of humanity are here on this world. Only 12 human beings, including Andy's dad, have ever ventured beyond this world to walk on the surface of another. Now, I've often called myself an orphan of Apollo because I was imagining the day when humanity wouldn't have to be dependent on one single planet, that we would become a spacefaring civilization. It is true that in geological sequences of history, not really much changes on a planet. Not much happens to a planet, but every once in a while, this happens. Every once in a while, a planet has a bad day. Ask any dinosaur. The dinosaurs didn't have a space program. And unless we are able to perfect the way that we humans become a multi-world species, this is going to happen again. Maybe next Tuesday, maybe not next Tuesday. But eventually, in the course of time, in the life of our sun, we have to become a multi-world species, for sure. All of life on Earth may depend on this. And one day we may have to avoid all of these mass demonstrations in Canada against global warming by understanding how other worlds work and thereby understanding our own planet better. One of the ways we're going to do that is by understanding our next world. Our next world, our sister world, the moon. It's a world full of vast resources. If we were the Polynesians looking out on the ocean and we saw the next island, wouldn't that be where we would want to go to learn how to navigate without GPS, using an astrolabe, using the sun and the stars? We're lucky that the moon is now an island in this planetary archipelago next to Earth that we can look out to as where we need to go, navigate by the sun and the stars. And we know now, because of not only the samples brought back from Apollo and by the Soviet Union through robotics, but through the vast information that's come to us from lunar probes looking down on the moon, that the moon has been aggregating resources. It's been accumulating these asteroidal materials that have been bombarding the moon for billions of years. All the platinum group metals, the nickel and silver, everything that we value here on Earth as an industrial civilization is there on the moon. What happened to the Earth happened to the moon. That's where everything that we care about comes from. So it's well mapped out. We know what the mineralogy of the moon is. Now we have to find out what the viable resources are to make it economically viable to go there. What makes it economically viable is the recent discovery of water on the moon. Back in the day of Apollo, I thought it was a dead, dry rock. How many people here watched Buzz Aldrin walking on the moon through TV? All right, look at that, including our friend Moses. Didn't we have an expectation watching that happen that our future was going to be one of vibrant exploration of space? Didn't we think that the moon was maybe not part of that? Well, now we know it is, because the water on the moon is the oil of the solar system. Water and its constituents, hydrogen and oxygen, is rocket fuel. We don't have to take all the fuel with us in order to explore a new world. We can refuel once we're there, and that is a game changer, not just for the moon, but for the entire solar system. And my company, Moon Express, that is now piloted by an Aldrin. When you're going to land on the moon for the first time, it's always good to have an Aldrin and a pilot seat. Welcome to the Moon Rush. We're going to explore the moon not just for the science, but for the value of the resources. We're going to bring something back. And this will be the private sector this time. And we're going to replicate what the superpowers did. Only 3 superpowers have ever landed on the moon. China just last December. Before that, only the United States and the Soviet Union. And now this will be in the realm of resources accessible to you and me. We're going to explore new wonders of the moon. We're going to expand the economic sphere of Earth outward, so the moon will become part of our civilization. There will be children born on the Earth, not too many years from now, who will look up at the moon and see lights on the moon and know that we on Earth are not resident just on one world, but on 2 and eventually many. We have a small team at Moon Express that is building its momentum. I'm so privileged that the hero of my childhood, Buzz Aldrin, what I called myself an orphan of Apollo, now the father of Apollo, I have the honor of working with the son of Apollo, Andy Aldrin, to help us get there. And it's Andy who's going to tell us how we're not just going to boldly go like his dad did, but how we're going to boldly stay. Andy, would you please do that? Andy Aldrin, everybody.
Thanks, Bob. Thanks, Dad. No pressure there, huh? So, the real question is, how are we going to do this? I mean, the technology is there, But, you know, in 2003, President Bush announced that we're going to go back to the moon. Okay? We're going to go there for the nifty sum of about $170 billion over the next 20 years. Well, at the time, I was at Boeing, and about a year into that program, I took the job running business development. The idea of running business development at Boeing for a $170 billion program sounded pretty good. Life sounded good. Well, so a funny thing happened on the way to the moon. Right, 2005, new administrator comes in, redirects the program. 2010, new president comes in, redirects the program. Well, so we're 2014, and I think the plan is that we'll fly the first piloted version of the next generation of exploration vehicles, which may or may not go to the moon, in 2021. So it kind of occurred to me that we're not quite on the right track here. Something that we do has got to change. We've got to do something different. Whether it's faster, better, cheaper, we've got to do something different. And so I looked out in the community and I noticed that there is actually a lot of stuff going on that is different. People are doing things with less money and in less time. So I jumped ship. The opportunity to help pilot a company that's going back to the moon was just something I couldn't possibly resist. But you know, the way we're going to do this isn't by the application of new, phenomenal technologies that are all out there. It's really by basically a sort of application of existing technologies in sensible ways, and through doing things sensibly, you can actually achieve order of magnitude results. And that's some of what we're trying to do at Moon Express. So the first principle of it is you get small, okay? Over on the right, that's the lunar module. It's about 20,000 kilograms. It isn't actually my dad's, because there's mountains in the back and stuff like that. Over to the right is the Moon Express MX-1, about 600 kilograms. Okay, so that being small makes a big difference. First place it makes a difference is in clickers. Okay. First place it makes a difference is by being small, you don't have to buy an entire launch vehicle. Right? In typical satellite, it's 5,000, 6,000 kilograms, takes up the entire payload fairing. When you're only 600 kilograms, you can sit down here. This guy pays for the majority of the launch. So now the cost of your launch has gone down by an order of magnitude. Now, up to this point in time, what these are called secondary payloads have primarily been small, one-off, relatively inexpensive scientific payloads. They're kind of hitchhikers. Well, hitchhiking is a pretty good way to get to the beach when you're a kid in high school. And I was a kid, grew up in California, I know something about it. It was a long time ago, it was a little safer then. One of the things I learned about hitchhiking to the beach is it works a lot better if you've got a six-pack. Right? You got to think about it in terms of what's good for the guy with the car or the truck or the bus. So there's really, it's not a technology problem. We've done over 100 ride shares over the years. The fundamental problem is almost a business contractual problem. This guy here, or this guy here, owns the whole rocket. If you simply put the rocket in the hands of the launch vehicle provider, now all of a sudden he owns all the payload margin. He's incentivized to sell something to this guy because it might reduce the price and make him more competitive there. It's starting to happen. It's starting to happen with commercial. It's even starting to happen with NASA, and the Air Force and DoD are starting to think about these things. Simple change, order of magnitude results. Next thing I want to talk about is, so you want to get small, and how do you get small physically? One of the things is just about doing sensible avionics. So the thing about avionics in a spacecraft is, typically spacecraft are really big, they're really expensive, billion-dollar spacecraft. You don't want the thing to fail in space. Nobody wants to fly electronics that haven't flown in space. As a result, you're flying really old, relatively old, obsolete electronics. So if we look at we went out and looked for an electronics box for our spacecraft, that's it, 34 kilograms. Now, our guys said, look, there are better ways of doing this. In some cases, you need to have highly qualified space-rated electronics, but in a lot of cases, you can use stuff that's been tested commercially, use it redundant, And our box, that box is now this board, okay? Sensible use, existing technology, not quite order of magnitude results, but we can do this stuff today. So I want to turn to propulsion. I mean, I can't design the whole spacecraft for you in the next 5 minutes, 2 minutes, but I do want to hit on a few points. Another key is propulsion. So traditional engines, this is a real traditional one. This is actually the one that powered the Saturn V first stage. Many years, billions of dollars to develop. In fact, NASA's looking at a new generation of upper stage, which is a much smaller engine. It's probably going to be about 10 years and over $1 billion. There's got to be a better way. So the other day, actually next week, we will be testing an engine, about 1,000 pounds. So it's not a huge engine, but it's big enough. This thing didn't exist as anything other than a good idea 4 months ago. 4 months from design to test stand. And we do it by scaling back, if anything, on technology. We do it by having higher margins, by using simple propellants that are non-toxic, that operate at room temperature. Simple ways of doing things, order of magnitude results. At the end of the day, though, it really all comes down to the people. So Apollo, lots of people. This is Woodstock. Yeah, I'm not sure if it had, okay. What does that have to do with it? About 400,000 people went to Woodstock. That's the number of people that worked on Apollo. A lot of people. We have a lot less people working at Woodstock. Average age of the engineers working in Apollo was mid-20s. Mid-20s. Today it's mid-50s. So at MoonX, and I think this is characteristic of the rest of the new space industry, at MoonX 60%, 65% of our employees are under 30. And there's a really interesting dynamic. So we've got these guys here in Silicon Valley, a lot of whiz kids. Maybe that guy right there. Right. A lot of whiz kids from Silicon Valley, brilliant people in avionics, software, vehicle design. And then we got the Rocket City rednecks here in Huntsville. These guys are the people that went from drawing board to firing something in 4 months. And it was just, now the brilliant thing is, how do you get these people to work together? Now I can tell you as a manager, when it works, it's absolute magic. But at times, there's some problems with combustion stability, you might say, with these groups working together. But it's been an amazing experience. And I just got to say that I think this is sort of the future of, or at least it's where the dynamic things are happening in space today. And I personally am delighted to be on the right side of evolution. I thank you very much.
You've come a long way. We've only heard from you for literally a few moments. Will you be at our party this evening?
Absolutely. We wouldn't miss it, Moses.
And if you are at the party this evening, you will have the privilege of speaking directly to Andy and to Bob.
Thank you.
As will I, because I miss you.
I miss you too, man.
See you in a long time.
All right. We'll see you tonight.
All right.
Thanks for being on.
Thanks so much. Great to meet you.